Hello everyone, welcome back to WarVerse Conflict. Today the world watches in shock as the Crimean Bridge, one of the most strategic and heavily guarded structures in Eastern Europe, becomes the center of roaring explosions, firestorms, and precision strikes. Stretching across the Kerch Strait, this bridge is not just concrete and steel, it is a lifeline connecting Crimea with mainland Russia, a symbol of control, logistics, and power. From the outside, the bridge appears massive and intimidating, an engineering giant rising above dark waters, reinforced by layered defenses, surveillance towers, radar systems, and patrol routes. Its long spans, road and rail sections, and fortified pillars were designed to survive harsh weather, heavy traffic, and even military threats. Yet under the glow of fire and the echo of thunderous blasts, the exterior tells a different story. Flames lick the roadway, smoke columns rise into the night sky, twisted metal hangs over burning sections, and shockwaves ripple across the water. Drones descend silently before impact, missiles cut through the air with terrifying speed, and each explosion sends debris crashing into the sea. The exterior, once a symbol of strength, becomes a battlefield where technology, timing, and tactics collide in seconds. Inside the Crimean Bridge system lies a complex internal world that few ever consider. Beneath the surface roadways and rail lines runs a network of structural supports, power systems, communication cables, sensors, and maintenance corridors. These internal elements act like the nervous system of the bridge, carrying data, electricity, and control signals that keep traffic flowing and safety systems active. Deep within the pillars and spans are reinforced steel frameworks designed to absorb vibration, resist blast pressure, and distribute load evenly across the structure. During an attack, this interior becomes the true test of resilience. Shockwaves travel through concrete chambers, electrical systems flicker or shut down, internal fire suppression systems activate, and emergency sensors detect temperature spikes and structural stress. The interior paragraph of this story is massive because the real battle happens where cameras cannot see. Engineers designed these internal spaces to delay collapse, to buy time, to prevent a single strike from triggering total failure. Yet repeated drone impacts, secondary explosions from fuel or vehicles, and missile strikes overwhelm these systems. Internal beams bend, cables snap, rail supports crack, and the sound inside becomes a terrifying mix of groaning metal, collapsing concrete, and raging fire. This hidden interior determines whether the bridge survives hours, days, or falls into the sea. Performance is where the Crimean Bridge once stood unmatched. Built to handle thousands of vehicles per day and heavy military logistics, its performance metrics included high load capacity, dual transport routes, and rapid traffic flow between Crimea and Russia. Militarily, it performed as a critical supply artery, moving fuel, ammunition, armored vehicles, and troops with efficiency. In combat conditions, performance shifts from traffic flow to survival under attack. How many strikes can it take before operations halt? How quickly can repairs begin? During drone and missile assaults, performance is measured in resilience, damage containment, and operational downtime. Each blast reduces capacity, shuts down lanes, halts rail traffic, and disrupts logistics. Fires weaken steel, explosions fracture supports, and even limited damage forces full closures due to safety risks. The performance degradation is immediate and strategic. What once functioned as a smooth, constant flow becomes a choke point, slowing reinforcements and exposing vulnerabilities. In modern warfare, performance under fire can reshape entire fronts. Safety features were a cornerstone of the Crimean Bridge's design. These included surveillance cameras, motion sensors, radar detection for low-flying objects, patrol boats, air defense coverage, and layered security zones. Structurally, safety meant blast-resistant materials, expansion joints to absorb shock, fire-resistant coatings, and emergency shutdown systems. Traffic safety systems could halt vehicles instantly, reroute trains, and activate evacuation protocols. Yet modern warfare evolves faster than static defenses. Small drones flying low evade radar, swarm tactics overwhelm defenses, and precision missiles exploit timing gaps. Safety features still play a role by reducing casualties, slowing collapse, and preventing chain reactions, but they are no longer absolute shields. Each successful strike exposes how even the most advanced safety systems can be stretched beyond limits when faced with coordinated, intelligent attacks. Safety today becomes damage control rather than prevention. The unique selling points of the Crimean Bridge are what made it a strategic icon and a prime target. It is the longest bridge in Europe, a dual road and rail connector, a political symbol, and a logistical backbone. Its location makes it irreplaceable in the short term. No alternative route offers the same speed or capacity. From a military perspective, its uniqueness lies in how much depends on it. Disrupting this single structure sends shockwaves through supply chains, command planning, and morale. The bridge's visibility also makes it a psychological target. Images of flames and explosions travel instantly across the world, shaping narratives, influencing public opinion, and signaling capability. In modern conflict, perception is as powerful as destruction, and the Crimean Bridge delivers both when attacked. Price, in this context, is measured not in dollars alone, but in strategic cost. Financially, the bridge cost billions to build and requires enormous resources to repair after each attack. Each damaged section demands specialized materials, skilled labor, and time under threat of renewed strikes. Economically, closures disrupt trade, tourism, and regional stability. Militarily, the price includes delayed supplies, rerouted logistics, increased vulnerability of alternative routes, and the need to allocate additional air defense and naval assets. Politically, the cost is measured in credibility and control. Every successful strike raises questions about security guarantees and future resilience. The true price continues to rise with every explosion. Every night the bridge remains partially closed, every image of fire reflected on dark water. As the smoke clears and the flames slowly fade, the conclusion is unavoidable. The Crimean Bridge in flames is more than a dramatic headline. It is a case study in modern warfare. Drones, missiles, and thunderous blasts have transformed a symbol of permanence into a reminder of vulnerability. Exterior strength can be scarred, interior resilience can be overwhelmed, performance can be degraded, and safety features can be bypassed. Unique strategic value turns infrastructure into a battlefield, and the price paid echoes far beyond the structure itself. This bridge stands at the intersection of engineering and conflict, where steel meets strategy and fire meets geopolitics. What happens next will shape supply lines, military decisions, and the narrative of power in the region. One thing is certain. In the age of precision strikes and relentless technology, even the strongest bridges are no longer untouchable.